Hey, what's going on, guys? I know you guys are super excited or super happy that Turkey Week is over. I'm exaggerating. I know you guys are maybe a little sad that Turkey Week is over, but don't be sad, guys. Be happy that it happened, and hopefully you got to experience some super awesome memories. And if you didn't, I'm sorry, guys. We had some math, and we get to experience these memories. So if you're seeing this before the official end of Turkey Week, which I guess is Sunday, kudos to you. And if you're not seeing this until we get back from school, that's all good, guys. All right, let's go ahead and start. And we missed you guys, and here we go. Let me put this in tablet mode. All right, so it says use differentials to estimate the value of the cube root of 66. So what we're going to do, we're just going to find a tangent line, just like what we're going to be doing on Monday for the notes. So we're going to find a tangent line, and the first thing we got to do is figure out a perfect tangent line. So I'm going to write y equals square root of x as y equals, not square root, cube root of x. Excuse me, guys. So I noticed that they want us to figure out what the cube root of 66 is. So we're going to pick a number that is close to a perfect cube root, and that number is 64. So you're just going to have to know some of these numbers, guys, some of the perfect cube roots. So here we go. So I'm going to write the cube root of 64 is 4. 4 times 4 is 16. 16 times 4 is 64. So immediately I already have a coordinate, 64, 4. So in case you want a visual of what we're doing, here's what we're doing. We're finding, like if you were to graph y equals the cube root of x, it would look something like this. Vertical tangent there. It would look, and I'm exaggerating it right here, guys. So I'm going to say that's 64, and then there's 4. And then what I'm doing is I'm finding a tangent line, and then if you were to zoom in on that tangent line and you go to 66, 66 is practically on the curve, because that tangent line and that curve are almost the same when you zoom in around the 64. So that's what we're doing. And obviously, if you were to ask, is my approximation going to be greater than or smaller than the real cube root of 64 or cube root of 66, it's going to be an over approximation because I'm above the curve here because I'm using that tangent line. All right, so here we go. So y equals x to the 1/3. So y prime equals 1/3 x to the negative 2/3. So I want my derivative evaluated at 64, because that's where I want my tangent line. So 64, and I'm going to write 1 over 3, the cube root of 64. So you don't need a calculator, guys. Relax. Look, 1 over 3. The cube root, oh, no, there's a square. Yeah, sorry, guys. So do the cube root first and then square it. The cube root of 64 is 4, and 4 squared is 16. It doesn't really matter which one you do first because they're the same value, quote unquote. And now, let's see, 16 times 3, 16, 32, 48. 1 over 48. All right, so here we go. Tangent line. Y minus 4 equals 1 over 48, parenthesis, x minus 64. I'm going to plug in a 66 in here because that's what you want to approximate, the cube root of 66. So I'm using this tangent line to figure that out, guys. 66 minus 64 is 2. So y equals 1 over 48 times 2 plus 4. Well, let's see what that is. 2 goes into 48 24 times. So I'm going to write 1 over 24 plus, and I need a common denominator. So I'm going to multiply 4 times 24. 24, 24, 24, 24, that's 96. So 96 over 24. 96 plus 1 is 97, so there it is. This is my approximate. I hope you guys like that, guys. I thought that was kind of cool. All right, let's do this one here. Use differentials to estimate. Again, it says the fourth root here, so I'm going to write y equals the fourth root of x, and I got to think of a number that's really close to 16.2, where that's a perfect fourth root, and I can think of 16. So the fourth root of 16 is 2, right? Because fourth root 16. You can break this up into 2 times 2 times 2 times 2. Look, 4 of them. So there it is. There's my point. Now I got to find my slope. So y prime equals, let's see, this is x to the 1/4. So I'm going to write 1/4 x to the negative 3/4. We might have some issues. We'll see. So y prime at 16 equals 1 over 4 let's see, the fourth root of 16 cubed. No, we're not going to have issues. All right. 16 to the 1/4 power, the fourth root of 16, we already said was 2. So this is 1 over 4 times 2 to the third. And then 2 to the third is 8. So 1 over 8 times 4, 8, 16, that's 32. So there it is. There's my slope. So I'm going to write y minus, the y value is 2. I'm finding my tangent line, guys. This is my tangent line. 1 over 32, and then I'm going to write x minus 16. So what am I going to insert for x? I'm going to insert 16.2. So I'm going to have y equals 1 over 32. 16.2 minus 16, that's 0.2. That's the same thing as saying 1/5 plus 2. I hope I didn't get anyone lost. Let's see. 32 times 5. I think we can do this without a calculator. Let's see. If it was 30 times 5, that would be 150, but that's a 2, and I did that 5 times. 2, 4, 6, 8, 10. So that's going to be 160. So 1 over 160 plus, okay, multiply 2 times 160. 16 and 16 is 32, so that has to be 320 over 160. So look, check that out. 320 plus 1, 321 over 160. There's my approximate. Yay. Hopefully you guys are liking this, guys. All right, let's keep going. All right, use differentials to estimate the value of cosine 56 degrees. I don't like that they use degrees, but that's fine. We're going to have to compensate for that. So we're going to use something that's really close to this, so like 60 degrees. So I'm going to say, I'm going to find a tangent line, so I got to use a model. So I'm saying cosine of, let's see, pi over 180 times x, close, where x is a degree. So as you can see here, if I plug in a 60 degrees, 60 over 180, that becomes 1/3. And 1/3 of pi is, cosine of pi over 3 is, let's see, 60 degrees and pi over 3 cosine, that's a half. So that's my coordinate right there, guys. So pre-cal's never going to go away. You got to know at least the basics, guys. So please make sure you know the basics. So here we go. I need a slope, because I'm going to use my tangent line to approximate what cosine of 56 degrees is. So y prime, at the moment just of x, is equal to pi over 180, and because it's a cosine, I'm going to have a negative in front, sine of pi over 180 x degree, close. All right, I'm going to plug in 60. Why am I plugging in 60 and not 56? Because I'm trying to find my tangent line first. So I'm finding my tangent line at 60 degrees, and I'm going to use that tangent line to approximate what my y value is when I'm at 56. Hopefully that made sense. So here we go. Y prime of 60 degrees equals negative pi over 180 times, let's see, if I put 60 in there, 60 over 180, that's pi over 3, or that's, yeah, pi over 3, sine of pi over 3 is square root of 3 over 2. So when I do that, I get a negative pi square root of 3 over 360. All right, that's my slope. Here we go, guys. I'm going to find out what my y value is, my new approximate. There's my tangent line. Y minus a half equals negative pi square root of 3 over 360, parenthesis, x minus 60 degrees. I'm going to plug in 56 right here. When I plug in a 56 minus 60, that's a negative 4. So I have y minus a half. Or you know what? I'm going to move the half already, guys. So I'm going to have y equals negative pi square root of 3 over 360. And really, this y is my approximate y value, guys. Times the negative 4 plus a half. All right. Well, negative 4 goes into 360 90 times, but there's a negative there. Negative times a negative is a positive. So let's see. I'm going to have pi square root of 3 over 90 plus a half. And I look for that. All right. Taking ln of 2 equals approximately 0.69. Use differentials to estimate ln of 2.2. So they're already giving me pretty much what I want, guys. I'm going to use y equals ln of x. So pretty much already telling me my x value is 2. My y value is 0.69. So there it is. So 2 comma 0.69. I might need a calculator. So far I haven't had to use one yet. So I'm going to take my derivative. So y prime equals 1 over x. you plug in your tangent line at 2, because that's what you have here. So my slope is simply a half. So let's see, I don't think we're going to need it. Y minus 0.69 equals 1/2 parenthesis x minus 2. I'm trying to approximate 2.2. So that's the number I'm going to plug in there. So I have, let's see, 2.2 minus 2 is 0.2. So y equals half of 0.2. I could say 1/5 again, but the 0.69 here is in decimal. And no, it doesn't look like I need my calculator, guys, so I got lucky. Half of 0.2 is 0.1. So 0.1 times 0.69 is 0.79. So there it is. All right, here we go. Find the differential dy for y equals. All right, so that means pretty much take my derivative, guys, just like we did on Monday's notes. Well, we haven't even done Monday's notes yet, right? So here I am. I'm already getting ahead of myself. All right, so just take a derivative. So I'm going to write dy dx equals, and I'm just using product rule. Check it out. First, 5x squared times the root of the second. The derivative of the second is cosine x plus second sine x times the root of the first, which is 10x. So now I'm going to rewrite it. Dy dx equals 5x squared cosine x plus 10x sine x. And then I'm going to multiply all of it by dx to get rid of the dx in the bottom. So times dx, so dx goes right outside. So dy equals, and they told me to replace my delta x, which is the same as dx, guys, but dx is like for smaller numbers. So they told me to replace my dx with h. So dy is equal to 5x squared cosine x plus 10x sine x, close it, change in x. And there it is right there. All right, hopefully you guys are having fun. All right, consider the function f of x equals x to the 2/3. Approximate the change of x as x changes from 8 to 9. Okay, these can be a little confusing, but I'm going to show you how to do it, and you'll get it right every time. So here we go. So first, we're going to find dy dx. So I'm going to write dy dx is equal to, and I'm going to rewrite this as 2/3 x to the negative 1/3. So I'm going to rewrite it as 2 over 3 x to the 1/3. All right, so now I'm going to multiply this by dx. So I have dy is equal to, because that's what they want. They approximate the change in f. So that's like finding your dy there, the difference in y. So 2 over 3 cube root of x, and then that times dx. All right, so what you're going to plug in for this one, you're going to plug in your 8. That's where you started off. And then what you're going to plug in for dx, you're going to plug in the difference between 8 and 9. So you're going to do 9 minus 8. So your dy is equal to 2 over 3, and then the cube root of 8 is 2. So these 2's cancel out. And then the dx, 9 minus 8 is 1. So I get 1/3. And you're only doing that because it says approximate. So some of you are maybe thinking, Chavez, why couldn't I have done f of 9 minus f of 8 over 9 minus 8? And you're going to see, you could have, but that would not have been approximate, guys. This would have been exact. And this value here would have actually been something really, really close to 1/3. So I don't know if you want to try it. Go ahead and try it. It's going to be like 0.34 or maybe 0.32. Hold on. It's going to be like 0.32. It's going to be an under approximate. Yeah, check it out. Try it out, and you'll see. Or the 1/3 is an over. All right. Cool. All right. Let's keep going. You'll get it. You'll understand it much better with this one, guys. A spherical ball bearing will be coated with 0.06 centimeters of protective coating. If the radius of this ball bearing is 10 centimeters, approximately how much coating will be required? So the key word is approximate. So we're going to use differentials. So you have a sphere, and this sphere has a coating of paint and 0.06 centimeters. So that's how big the coating of this paint is in this sphere. So if you wanted to find the exact, you would go 4 pi, 0.06, the radius is 10, so 10.06 to the third, 4 pi r cubed minus 4 pi, and then 10 cubed. So this is exact, but I don't want exact. I want approximate, so I'm going to do with differentials. So my volume is 4/3. Oh, sorry, it had to be a 4/3 down there. 4/3 pi r cubed. So you would have to do the 4/3 pi r cubed minus 4/3 pi r cubed, whatever. So this is my volume, and I'm going to find my differential, dV dr, and it comes out to 4 pi r squared, dr dr. So there it is. So times dr, so my dV equals 4 pi r squared times dr. So here's what I'm going to do. For r, you're going to plug in 10 centimeters. And then for dr, that is your 10.06 minus the 10. So that means 0.06. And we are going to have to use a calculator because they want us to use a 0.314. So I'm going to write 4 times pi times 10 squared times 0.06. And when I do that, I have my calculator right here. They don't want us to use pi, guys. They want us to use 3.14. So that's what I'm going to do. So 4 times 3.14 times 10 squared is 100. So times 100 times 0.06. And I get 75.36. So there it is, guys. If you were to do it this route, you would probably get a number really close to it. Probably a little bigger, 75.7 or 75.6 or something like that. Yeah, you would get something very similar. So if you want to try this out, let me know what it is. I would try it out just so you guys can see what's up. This is the approximate, and this one right here is the exact, if you wanted to know that dV there. But this is the approximate, 75.36. All right, now it just looks like we're just doing regular derivatives. It doesn't look like there's anything special. So let's give the derivative of this function at the point where x is 0. So this is our tan. So here it is. Here's my derivative. F prime of x is equal to 1 over 1 plus whatever I have on the inside squared. So e to the 10x, close it squared. If you want to say e to the 20x, that's fine. Times the derivative of e to the 10x. So that's e to the 10x times 10. So f prime of x is equal to 10 e to the 10x over 1 plus e to the 10x squared. And again, if you want to say e to the 20x, you can. F prime of 0 equals e to the 0 is 1. 1 times 10 is 10. E to the 0 is 1. 1 squared is 1. 1 plus 1 is 2. 10 divided by 2 is 5. All right. Is this the last one? No, it isn't. Find the derivative, and notice that my exponential has an x on it. So we're going to have to do it like this, guys. So y equals 3x plus 4 to the 5x. So before we can take a derivative, we're going to have to bring that 5x down. So I'm going to do ln on both sides. So that will bring that down. So now I have ln of y equals 5x ln of 3x plus 4. So now I can take a derivative. So the derivative of ln y with respect to x is 1 over y dy dx equals, and then product rule right here. First times derivative of the second, 1 over 3x plus 4 times 3 plus second ln of 3x plus 4 times derivative of the first, so 5. So all this goes together. So times y. So I'm going to write dy dx equals y, giant parenthesis. So let's see, that's a 5, that's a 3. 5 times 3 is 15, so 15x over 3x plus 4, nothing cancels, plus 5 ln 3x plus 4, close. And remember that y equaled 3x plus 4 to the 5x. So I'm going to replace that for that one, and then I just look for it. So here it is. 3x plus 4 to the 5x times 5 ln 3x plus 4 plus 15x over 3x plus 4. Perfect. Yay. All right, let's do another one, guys. Let's see. This one says, given f of x is negative 3x cubed minus 2x minus 9, verify that f of x is invertible. So that means has an inverse. If so, find the equation tangent line of the point where x is negative 14. Note that f of 1 is negative 14. Okay. If this minus 9 were not here, we would say that's a not function. And every odd function has an inverse. So make sure you know that, guys. Every odd function has an inverse. So if I had 3x cubed minus 2x, it would be, by definition, an odd function. And that minus 9, all it does is vertical shift down 9. So yes, it has an inverse for sure, guys. For sure. Okay, so now that we got that out of the way, all I need is the slope of my inverse where my inverse function is negative 14. So since we know the relationships between the original and your inverse function, I can just find my derivative at 1 and just take the reciprocal, and that's going to be my slope of the inverse. So here's what I'm trying to say, guys. So the derivative at negative 14 is nothing more than the reciprocal of the derivative of f at 1. So I need to find f prime of 1. So here we go, guys. F prime of x equals negative 9x squared minus 2. So f prime of 1 equals negative 9 times 1 squared minus 2, so negative 11. So now that I know that my slope for my tangent line for my inverse is the reciprocal, so 1 over 11, negative 1 over 11. So here we go. My point is negative 14 comma 1. This is my x on the inverse, and this is my y on the inverse. So I'm going to write y minus 1 equals negative 1 over 11, x minus a negative 14, so plus 14. And now I look for that. Yay. I hope you guys enjoyed this video, guys. I'm glad to be back. I hope you guys are glad to be back in school. I'm really excited, and I'm really happy for this, guys. All right. Take it easy, guys. See you guys later. Bye.